Hi, I am Karthik and Rannan. I am the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me, so I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it. Thank you.
Hi, I am Karthik and Rannan. I am the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, help the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me, so I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it. Thank you.
Hi, I am Karthik Rannan. I am the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me, so I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it. Thank you.
Am I audible to all of you guys? Guys, am I audible? Yes or no? Okay, great. So, let me share my screen. Okay, guys. Is it visible to all of you? Okay, so I hope my screen is visible to you guys. Okay, great. Thanks for the confirmation, guys. Don't worry, Madhu. All of these materials will get uploaded by next week, right? So don't worry about that. Okay, so let's start with the session, guys. So yesterday, we have started with something called as a generative AI. Right? And we understood what are these generative AI models. And then we also saw a couple of, uh, like what are the examples of these generative AI models or some applications like ChatGPT and all. And then we have explored a little bit about ChatGPT. And we saw there are two versions of the ChatGPT. One is a free version, which is a GPT 3.5. And then one is a paid version, that is a GPT 4. Right? And can you guys tell me what is a full form for GPT? What is a full form for GPT, guys? Anyone? No, Shruti. Yes, Madhu. Yes. Yes, Beprajit. Correct. So it stands for the generative pre-trained transformer. So generative pre-trained transformers. Right. So this is a full form for GPT. And actually, it is one of the deep learning based model which is working behind the ChatGPT. Right. Now, to understand, these transformers, you need to have a idea about sequence to sequence model. So yesterday we saw what is the sequence to sequence model, very basic detail. Like, so in the case of sequence to sequence model, we have an input, which is a sequence of words, and it generates an output, which is also a sequence of words. So that's why we have something called the sequence to sequence. So the first sequence is for the input, second sequence is for the output. So this kind of a model will take input as a sequence of word and it generates this output as a sequence of words, right? But to understand this sequence to sequence model, you need to understand something called as a LSTM model or LSTM architecture. So there is something called as a LSTM architecture. To understand this LSTM, you need to understand what is a RNN network. So I will come to like all of these terminologies, but for the timing, let's understand this chain. And to understand this RNN network, you need to understand neural networks. neural networks. Right? In short, NN. So, I mean, if you want to understand what is the technology behind the ChatGPT, you must have a basic knowledge of the neural network. What is the RNN network? What is the LSTM? What is the sequence to sequence model? And then you can understand what is the transformer. Right? So this is the chain what we have, like to understand these things. So in today's session, we will try to understand what is a neural network. Right? And if time permits, I will, show you a couple of more hands-on with the ChatGPT. So this is the agenda for today's session. Okay. So to begin with, guys, let me give you a top view of the deep learning, domain. Like, what are the things are there in the deep learning? Okay, so that you can, have a clear-cut idea what actually we are studying. So, when it comes to the deep learning, guys, we already saw what is the difference between deep learning and machine learning. Right? When it comes to the deep learning or AI, so whatever AI models we have or AI, applications we have, those are using deep learning concepts. So in the deep learning, guys, whatever models or architecture we have, all of those models or architecture, they are built using the something called as a neural networks. So you can say that neural network is the backbone for deep learning architectures. I'm repeating it again. When it comes to the deep learning based models or architecture, all of these models are utilizing something called as a neural network as an architecture point of view. So we can say that neural network is the backbone for all of the deep learning models or the, whatever architectures we have. Okay, so when it comes to the deep learning, guys, so here we have a different kinds of a neural network for different purpose. For example, we have a something called as a ANN. ANN stands for artificial neural network. Artificial neural network. So A stands for artificial. Artificial neural network. So this kind of architecture, this ANN kind of architecture, we use for two purposes. If you want to, build a regression model or classification model. Classification model. So if you want to build a regression model or a classification model, then we can go with this kind of a neural network architecture, which is called as a artificial neural network. We already saw one of the classification based model over the text data. All right. So we saw the text classification model using the logistic regression and nav base. So those logistic regression and nav base, these were the machine learning based approach. Right? But if you want to perform the classification kind of a task using the deep learning based approach, so we have something called as a ANN. Right? It is also used for regression based models. So this is the first kind of a neural network what we have. Apart from that, we also have something called as a CNN. So CNN stands for convolutional neural network. So C stands for the convolutional. Convolutional neural networks. Right? This kind of a neural network architecture we mainly use for image or video processing. For image or video processing. right? Gagan, what is a regression model? So just like a classification model, where we at the output, what the model is doing, model is classifying each and every record, whether the record belongs to category 0 or category 1. This is what we were doing in the classification model, right? In case of a, like what case study we saw over the text data, there we were classifying our text data as either software or hardware in these two categories, or the category can be anything based upon your data set. When it comes to the regression model, actually we are predicting some numerical values. For example, let's say I want to predict the sales. Sales is one of the numerical values. Let's say sales of the car, right? Or let's say I want to predict the GDP or population. So these kind of things are numerical values, right? So if you want to predict some numerical values, so that is something we are calling as a regression model. If you're classifying the records in one of the category, so that is something called as a classification model. Is that clear, guys? Gagan, is that clear? The difference between regression and classification? Okay, cool. Okay, so I was explaining this point. Okay, so then we have something called as a CNN, convolutional neural network, and it is mainly used for image or video processing. So like in computer science, we have an specialized domain called as a computer vision. Computer vision. So this is a specialized domain what we have which deals with the image or videos. And in deep learning, if you want to implement the concept of the computer vision, we have something called as a CNN architecture, convolutional neural network. So there we have different models you can build, like image detection, object detection, object localization, image segmentation, image classification, like that. There are a lot of things are there. So this is one thing. Apart from that, we have something called as the third kind of a neural network architecture, that is something called as a RNN. RNN stands for the recurrent neural network. Recurrent neural network. So R stands for the recurrent. Recurrent neural network. Right? So these kind of neural network architecture, they deal with the sequential data. Sequential data. Right? So they deal with the sequential data. Now, what is a sequential data actually? The sequential data is nothing but the data which maintains some order. So that means, okay, so for example, let me just give an example of the sequential data. Let's say I have a data set like this. So here we have two variables. And let's suppose the first variable is a month. Second variable is a sales. Sales of a particular product, right? So in short, we have a month-wise sale for a particular product. Let's say in the month we have a Jan. Let's say Jan 23, Feb 2023, March 23, April 23, and so on. And let's suppose these are the sales. So let's say for Jan month, the sale was some $150, something like that. In the Feb, let's say 110. In the March, let's suppose 120. In April, let's say 93. And like that, we have a sales for each and every month. Now, if I ask you guys, can I shuffle this data set? That means, can I shuffle the records? So when I say records, I mean one row is a one record, right? Can I shuffle these records? I mean, can I make the March this particular record on the top and Jan, like this record at this place. Can I do that? Apurva is saying yes. What else, guys? Think logically, guys. Can I shuffle these records? No, right? Yes. I can't shuffle the record, guys. The reason being, if you make this particular row or this particular record as a first record, and let's say the first record at this place, if you see, we have a sales which is based on the month. So if you make the March 23 as a first month for the sales and Jan as after the Feb, is it possible that if you make the Jan after the Feb, so actually you are saying first we are getting the sales for the Feb month and then we are getting the sales for the Jan month. Is it possible? No, right? So that means that the data set which we can't shuffle or we can't change the order. This kind of a data set is called as a sequential data. In short, the data which is indexed by the time. Now the time can be, it can be a monthly basis, it can be a daily basis, it can be yearly, quarterly basis, even hourly basis, minute wise. The time can be in any of the frequency. If your data set is indexed by the time, that is something we are calling as a sequential data. Is that clear, guys? Yes. So these are all other ordered data. So the data maintains some order. You can't change this order. Cool. So this is something we are calling as a sequential data. I hope this point is clear to everyone. What about YouTube, guys? Okay. Okay, guys. So let's discuss a couple of more details. Okay. Let me clean this one. So, this is how we have a sequential data. So RNN is a network. It is a neural network, that is a recurrent neural network that deals with the sequential data. Now the sequential data, it can be a numerical data or it can be a text data. So accordingly, we have two applications. One is a time series forecasting. Time series, TS, is nothing but the time series forecasting. That means we are forecasting of a numerical data for future time instances. Forecasting. And we also have a text data analysis. Text data analysis. Right. So both are there in the sequential data processing. So for that, we have something called as a RNN network, that is a recurrent neural network. All right. Okay. Apart from these basic neural networks, so actually, simplest neural RNN neural network what we have, in that we have some issues. So like the basic RNN network is having couple of issues. So those issues were resolved by a modified RNN network, and this is what we are calling as a LSTM network. LSTM model or LSTM neural network. So LSTM is nothing but it is the modified form of the RNN network only. So LSTM stands for, guys, long short term memory. Long short term memory. This is what we are calling as a LSTM model. So actually LSTM model is nothing but it is the RNN model with some modifications. All right. So in that way, we have these things. So these are the some neural network based architectures, and then we have a something called as a generative AI domain. Generative AI as a separate domain which is coming nowadays, and in that we have a something called as a sequence to sequence model. These are also a neural network based architecture, but the sequence to sequence model is nothing but, guys, this kind of a architecture is utilizing LSTM as the base model. So that means like we have a combination of LSTM models in the sequence to sequence models. So ultimately, in this particular sequence to sequence model, we have a LSTM working at the backend. Right? So they are based on LSTM model, or it is called as a LSTM cells. Right? And then with this sequence to sequence model, we have a couple of drawbacks. Right? We have a couple of drawbacks. Those drawbacks are overcome by something called as a transformers. Transformers. And how transformer will overcome these drawbacks? So for that, transformer is using a specialized mechanism that is something called as a attention mechanism. So transformers with attention mechanism. Right? So this is how, guys, the things are arranged. So in this course, we'll be seeing some basics regarding the neural network in today's session. And probably in upcoming sessions, parallel to the ChatGPT hands-on, we'll be seeing some basic details regarding the RNN and what are the issues with the RNN, then what is the LSTM model, what is the sequence to sequence model. So these details we are going to see like in upcoming sessions. And along with that, we'll also do some hands-on with the ChatGPT. And not only the ChatGPT, I will also introduce you a couple of more AI-based applications like, as I mentioned in yesterday's class, Bing and BART. Okay. Madhu, this is not the right time to give to brief about the LSTM because you don't know what is a neural network, right? So first of all, I will cover the neural network, then RNN, and then we'll come back to LSTM part. Okay. Hussein, this is what in this particular slide, I'm just giving a basic details like what are the different architectures or models we have under the deep learning. Right? And guys, all of these models or architecture, all of these architectures are based upon neural network. So first of all, let's start with getting an understanding of the neural network part, and then slowly and gradually we'll be seeing this RNN, LSTM, and sequence to sequence model. So this is the idea like for upcoming sessions. Is that clear, guys? Any doubt or any queries? Anyone? Okay. So if this part is clear, so let's start with the neural network part. Let me remove this one. Okay, guys. Now, guys, if I ask you, what is an AI? What do you think, guys? What is an AI? We have already discussed all of these basic details. If I ask you what is an AI, what will be your answer? Anyone? Computer's intelligence, yeah. Think and act like a human. Exactly. Exactly, correct. So actually, AI is nothing but we are making machines so capable that machine can behave just like a human. Right? This is what we are calling as a AI. So ultimately, AI is nothing but just to mimic the human behavior. Yes. Yes, Gagan, correct. So enables machine to mimic the human behavior. Now, when it comes to the mimicking the human's behavior, so it is very important to understand how human can understand a particular situation, how human can process the information, and how human can respond. Then only we can mimic this kind of a behavior to the machines, right? So to understand how human can process the information and can react to a particular situation, so that is totally depends upon the brain's functionality, right? So that depends upon the human brain's functionality. And when it comes to the human brain's functionality, so let's understand how human brain will do the processing of different input signals. So in our human brain, we have a lot of neurons in our brain, and these neurons will process the information which is coming from different body parts, right? For example, let me just show you this thing. So in our brain, guys, we have a number of neurons present. These neurons will process the information, and whatever output these neurons will generate, this output pass to other neuron will again process the information, it pass to some other neuron, and likewise. So let's say in this particular diagram, each and every this yellow part is one neuron. So this is one neuron, this is another neuron, and likewise we have a multiple neurons in our brain. So let's understand how human brain performs the processing. So out of all these terms, just focus on these 2 or 3 terms. So one is a nucleus, one is a dendrites, axon, and synapse. These 4 terms, right? So what happened, guys? Whatever these thin connections you are seeing, this one, these are called as a dendrites in our human brain. The working of the dendrite is basically they are mainly responsible for to carry the input signals from different body parts. They will carry the input information or input signal from different body parts, right? And then each and every input signal is being associated some weightage, and that weightage is called as a synapse. So synapse is nothing but the weightage given to each and every input signal, so that the neuron can understand the input signal which is having a higher importance will have a higher weight, and the input signal which is having the lowest importance, for them we have some lower or lowest weight assigned. So accordingly, when the neuron will process these input signals, they can understand which input information or input signal is having the highest importance, right? So these weights is being assigned, that is something called as a synapse. Now with this weight, this input signal gets into this nucleus part, and this nucleus will perform certain kind of a processing, right? It will do some kind of a processing, and accordingly it will generate the outcome. Now whatever output is generated by this particular neuron, that is being passed to another neuron as an input. So this output is passed to another neuron with the help of axon. So axon will carry forward this output to another neuron. Right? Similarly, the other neuron will also do certain kind of a processing, and whatever output is generated, that is passed to some other neuron. So likewise, the information will flow from one neuron to another neuron. Is that clear, guys? What about YouTube, guys? Any questions to understand this concept? Okay. Okay, let me explain it again. Those who are getting some issue, they can also understand. Okay, guys. So let me explain it again. So guys, these are the different neurons what we have in our brain, right? And whatever these thin connections you are seeing, these are the different input signals we are getting from the different body parts. Based upon the requirement of the body, from the different body parts, these neurons will get the inputs, right? And this input is being carried forward with the help of dendrites. So whatever these thin connections you are seeing, they can contain the input signals, and these thin connections we are calling as a dendrites. Now how neuron will understand which input signal is having the higher importance, which input signal is having the lower importance? For that, it will assign some weightage to these input connections, right? So this weightage, you can consider it as some numerical value. So the input signal which is having the higher weightage, or higher importance, those will be having a higher weightage. For example, let's say this is the neuron we have. So let's say this is the nucleus of one of the neuron, and this particular nucleus is getting, let's say, 3 input signals. This is the first input signal, I1. Let's say we have another input signal, I2. And here we have another input signal from different body parts, I3. And let's suppose out of all these 3 input signals, the I3 input signal is having the highest importance. That means the brain needs to reply this particular input signal immediately. All right. So what it will do, how this nucleus will identify whether this input signal is having the highest importance, so based upon the weightage. So probably it will assign higher weightage to this input signal I3, let's say 0.7. And then let's suppose the second highest important signal is the I1. The second important signal is the I1. So it will assign, let's say 0.2 weight to I1. And let's say I2 is the least important signal. So let's say 0.1 weight assigned to this I2. So I mean, likewise, it will assign some weightage to each and every input signal so that the nucleus can understand which input signal is having the higher importance. Right? And then accordingly, it will perform certain kind of a processing in the nucleus with input signal and the weight value. And whatever output is being generated, that output is being carried forward by axon to another neuron. The other neuron will do similar kind of a functionality. It will perform certain kind of a processing, and again it will generate the response, and the response is being carried forward by axon to another neuron. So this process, this process goes on. So this is how our brain performs the functionality. Karan, this is what I'm explaining. Each and every neuron, this nucleus will do certain kind of a processing, and whatever output is being generated, that is, forwarded to other neurons. Yes, Sayyad, correct. So guys, this is what we have a brain's functionality. Now the similar functionality or this kind of a architecture is being replicated in artificial intelligence using deep learning, right? And that is what we are calling as a neural network. Okay. So first of all, let me just show you how a typical neural network looks like, and then we'll see a couple of more details. So, okay. So guys, this is what we have a typical neural network architecture in deep learning. So you can see here, we have this, blue bubbles, you can see. And if you see this one, so we have a 4 blue bubbles on the top of each other, right? So they are, some kind of a stack is there. So we have a 4 blue bubbles on the top of each other. And then here we have a 3 blue bubbles on the top of each other. Here we have a 2. Here we have a 3 blue bubbles on the top of each other, like that. So like if you see this particular set, so this is something we are calling as a one layer. This is another layer. This is another layer. This is another layer. This is another layer, right? So in the neural network architecture, we have a different layers, and for each and every layer we have this kind of a blue bubbles or blue circles. Now whatever these blue bubbles or circles you are seeing, actually these are nothing but the neurons, or in the deep learning they are also called as a nodes. Neurons or nodes. So each and every, this blue bubble is called as a neuron or node. So that means we have a multiple layers, and within each and every layer we have a certain number of neurons or nodes, right? This is first thing. Now apart from that, guys, if you see this particular architecture, so how many layers we have, guys? This is one layer. This is second layer, third layer, fourth layer, and fifth layer, right? So that means in total we have a 5-layer neural network. 5-layer neural network what we have, right? Now out of all of these layers, the first layer will always be the input layer. Last layer will always be the output layer. And the function of input layer is to get the data. So whatever, input data you have, that data is being fed to this input layer nodes, and they will carry forward this data to next layer nodes, right? And the function of the output layer is basically whatever output is being generated by each of these, neurons or nodes, that is our final outcome. Understood, guys, these details? Right? Now, apart from that, apart from that, so if you see in the input layer, what we have our original data, like whatever data we feed to this neural network for the processing. That is something we have in input layer. So except the input layer, all other layer nodes, so like this node, this node, this node, this node, this node, so all of these nodes will perform certain kind of a processing, right? Just like the human brain's neuron. So all of these nodes will perform certain kind of a processing, and whatever output is being generated by each and every node. For example, this node will perform certain kind of a processing. Whatever output is being generated, that output is passed to next layer nodes. So what is the next layer? This is the next layer. In this layer, we have two neurons or two nodes. So whatever output is being generated by this particular node, that is being passed to this node and this node. Same for this particular neuron. So this neuron will take input from the input layer and it will do certain kind of a processing. Whatever output is being generated, that is being passed to next layer nodes, like this, like this. Same for this one. It will generate the output and that is being passed to next layer nodes like this. And then this particular, second layer node will also perform certain kind of a processing. Whatever output is being generated, that is being passed to next layer nodes like this, this, and this. Same for this one. All right. So that means whatever these, black lines you are seeing, these are actually the connections. And if you relate this to our brain's functionality, these are nothing but the axons. They will take the output from one neuron and they will, carry forward it to the next layer neuron. Right? So this is the connection what we have. Okay. And then if you see, guys, so we fed data to this input layer. This data is being passed to the first layer node. This node will perform certain kind of a processing. It will generate the outcome and that is being, fed to the next layer node. Next layer node will again perform certain kind of a processing. Again, it will generate some, outcome that is being passed to the next layer node. This node will again perform some processing. It will generate the outcome that is passed to the output layer node. And this node will again perform some processing and it will finally generate the outcome. So in this particular, scenario, if you see, the data is flowing from left to right, like in this manner, right? That is, data is flowing in a forward direction. The data is flowing in a forward direction. That's why this kind of a network is also called as a feed-forward neural network. Feed-forward neural network. Or since the information is flowing in a sequential manner, right? Information is flowing in a sequential manner. These networks are also called as a sequential neural network. Sequential neural network. So these are the different names given to this kind of a neural network architecture. Is that clear, guys? These details? Any questions, anyone? YouTube guys? Yes, Siddhanta, weights are directly attached to our inputs, right? So in some time, I will show you how, like what kind of a processing these neurons will do. Okay. So then it will be more clear. Karan, like it depends upon like what kind of a data we have, but it can accept more than one input, right? Okay. Any other questions, guys? Anyone? Yes, Sayed. So I'm coming to that point. The number of layers and the neurons. I'm coming to that point. Don't worry. Okay, guys. So if these details are okay, there is one more question. Purpose of synapse in human brain. So basically, Amar Krishna, as I told you, like the synapse will is assign the weights. I mean, it's kind of a weightage which is provided to each and every input signal, whatever we are getting in our brain, so that brain can understand which signal is having the higher importance, and accordingly, it will generate the reply. Right? Amrita, I didn't get your question. Is neural network the sequence to sequence? Means what? I explained you guys, this kind of a network is also called as a sequential neural network. Sequence to sequence is something, like a different neural network architecture, right? Yes, Amrita, sequence to sequence model is something different. This is what we are calling as a sequential neural network. Okay. Any other question, guys? Anyone? Okay, guys. So, okay, there is one more question. Karan, hold on your question. I will explain all of these points. Okay, so let me share my screen. Okay, guys. So let's see a couple of more details regarding this neural network part. So we understood, guys, like in the neural network architecture, what we have a different layers. The first layer is called as the input layer. Last layer is called as the output layer. And guys, in between input and output, whatever number of layers we have, like in this case, we have a 3 layers. That is something called as a hidden layers. Right? So what are the hidden layers? The number of layers which are in between input and output layer. So in this network, we have a 3 hidden layers. So guys, when you are designing this kind of a neural networks, so it is up to you how many hidden layers you want to include in your network. Along with that, within each and every layer, whether it is an input layer or hidden layer or output layer, how many number of nodes will be there. So I mean, all of these things you can decide while defining the neural network architecture. Okay. So it is up to you. Okay, guys. Apart from that, if I talk about what kind of a processing is being done by each and every neuron. So like internally, what kind of a processing this node will do, this node will do, this node will do. So all of these nodes will perform 2 functionalities, and based upon that, it will generate the outcome. Right? So let me explain you like what is the internal processing of these neurons. For example, guys, if you take this particular neuron, so for this neuron, what are the input signals? So this is one of the input signal. This is second input signal. This is the third input signal, and this is the fourth input signal. And as we discussed, for each and every input signal, we have some weights associated. So that means for each and every input like this, and this, we have some weight value assigned. And accordingly, it will do certain kind of a processing and it will generate the outcome. Now, this processing is same for all of these neurons. So all of these neurons will perform two kind of a functionality. Let me explain you what are these things so that it will be more clear to you guys. Okay, let me explain it here. So let's suppose, guys, this is a typical neuron or a node I have. And for this neuron or node, let's say I'm getting two inputs. This is the first input. And let's suppose this input signal is having the value x1. Since the second input, for this input, the value is x2. So this x1, x2 is some numerical values, right? And we already discussed for each and every input, we have some weight assigned. So let's say for first input, the weight is W1. For second input, the weight is W2. Again, this W1 and W2, these are some numerical values, right? Now, apart from these inputs, guys, each and every neuron is getting another input as a bias connection. So there is something called as a bias connection, which is another input for each and every node. So for this bias, we only have a weight value. So let's say the weight is W0, right? So for this bias connection, we only have the weight value. Let's suppose the weight is W0. So like these are the, different inputs for any of a node. So this x1, x2 are the inputs coming from the previous layer nodes. This bias is something which we have for each and every node. So in total, for this particular example, we have three inputs, x1, x2, and this bias connection with the weight W0, right? So this connection is called as a bias. Now let's see what kind of a processing is performed by each and every neuron. So let me do like this. Okay. So guys, each and every node will perform two functionalities. Let me just divide into two halves. This is the first part and this is the second part. The first part we are calling as a adder function. Adder function. So each and every node, first of all, it will perform something called as a adder function. Whatever output is being generated by this adder function, right? Whatever output is being generated by this adder function, that is being input to the second part, and the second part is called as the activation function. Activation function. So this activation function, it will take output from, so it will take input as the output of this adder function, and it will do, certain kind of a processing, and accordingly it will generate the final output. So this output, if you have a next layer, so this output will fed to the next layer nodes, like this, all right? So let's understand this, adder function output. Okay. So guys, this adder function output is nothing but, it will just combine each and every input with their weightage value. So it's like we have a first input x1 with weight W1. So it will be x1 multiplied by W1. Second input, we have a x2 with weight W2. x2, W2. And then we have a bias with weight W0. So bias is nothing but it's the name of this connection. So the value is always 1. So 1 into W0. So plus W0. So this is the outcome of this adder function. And as I told you, this x1, w1, x2, w2, w0, these are some numerical values. So ultimately, you are getting some, a particular value as an outcome. That value will be the input for your activation function. So up to this, guys, things are clear or what? Are you guys getting up to this point? Okay, guys, cool. So if this part is clear, so let's see what is this activation function? And when it comes to the deep learning, what are the different types of activation function are there? So actually, guys, this activation function is nothing but these are, these are the functions. And by the way, it is also called as a transfer function. Sometimes it is called as an activation function, or it is also called as a transfer function. Right? So these are the functions which is used in deep learning model to introduce the non-linearity. And why we are introducing the non-linearity to our deep learning architecture? So that our deep learning model can extract the complex hidden patterns or behavior from the dataset. So to extract these complex hidden patterns or the behavior from the dataset, we are introducing the concept of activation function. Right? And there are a lot of activation functions are there. So let me just show you the list of these. Okay, yeah. So here, these are the different activation functions what we have. Sigmoid is one of the activation function. This is the formula for the sigmoid activation function. So what are these x you are seeing, guys, in this function? This is nothing but the outcome of the adder function. That is the input for the sigmoid function. tanh is another activation function. This is the formula for the tanh activation function. And this x is nothing but whatever output we are getting from the adder function, right? Adder output. ReLU is another activation function. We have a different forms of the ReLU like LU, leaky ReLU, SReLU, like that. Max out is another activation function. We have a softmax as another activation function. So likewise, we have, guys, different activation functions. So based upon these formulas, they will generate the final outcome for a particular node. Right? So if I come back to this one, so let's suppose this particular neuron or node. So what this node will do, it will perform two functionalities. One is the adder function, another one is the activation function. So what this adder function will do, it will just combine the input based upon their weightage. So this is the first input, I1, with weight W1. This is the second input, I2, with weight W2. This is the third input, I3, with weight W3. And this is the fourth input, I4, with weight W4. And apart from that, we have a bias connection for each and every node, guys. Whatever number of nodes you are seeing, for each and every node, we have a one bias connection with value as a 1 with some weight W0. And accordingly, it will combine all of these input value with their weightage. And that is the outcome of the adder function. This outcome is the input for the activation function. Now, what activation function we can choose, that is something, it depends upon the user. I mean, you can decide what activation function you want to select for this particular layer, for this particular layer, for this particular layer, for this particular layer. I mean, layer by layer, you can decide what activation function you want to apply. Let's say for first hidden layer, I want to apply ReLU. For second hidden layer, I want to apply, let's say, tanh. For third, again, I want to apply the ReLU. For output layer, let's say I want to apply sigmoid. So it's up to you, like what activation function you want to apply. And accordingly, based upon your activation function, each and every node will generate the response, and then that particular output will get fed to the next layer nodes. Is this processing is clear, guys? This internal processing? Any doubt or any queries, YouTube guys? Yes, Madhu. For a layer, we decide the activation function. So it's a layer by layer, right? Yes, Karan, you can understand like this. The current is flowing from one direction to another in a sequential manner. Okay, there is one question. What is the use of this bias? Okay. So for that, let me share. So I hope my screen is visible to you guys. Let me come back to that point. Yeah. So guys, there is a one question. What is the use of this bias connection? Let's say we have a weight W naught, right? This is the bias. So what is the adder output we are getting, guys? Adder output we are getting in this case, let's say this is the X1 weight W1, X2 weight W2. So the adder output is basically X1 into W1 plus X2 into W2 plus W naught, right? Now in this particular equation, this W1, W2 and W naught, these are the weights value, right? These are the weight. What is our input? Input is this X1 and this X2. These two are the inputs. So X1 and X2 are the inputs. W1, W3, W1, W2 and W naught are the weights. Right? These are the weights. Now, if I ask you guys, can you guys tell me what is the equation of a linear line? Linear line equation. Can you guys tell me? Karan, I'm not talking about the BIOS. BIOS is something different in the IT terms. It's a bias. All right? Yes, guys. Correct. So the linear line equation is a y is equals to mx plus c. Right? So in this equation, guys, if you see, this m is nothing but the slope. C is nothing but the intercept, right? So what is the input for this equation and what is the output? The input is the x. X is the input variable. So based upon the slope and intercept value, if you provide any input, we can get the output as a y. Yes or no? Right? Okay. So that means, let's suppose, for example, let's say my m is a, let's say my slope is a, for example, let's say slope is a 1. Okay, let's say slope is a 2 unit, and the c intercept is a, for example, let's suppose it's a 10. Now if I provide x equals to 5, can you guys tell me what is my output y? Anyone? 20, right? Y will be 20. If I make x equals to, let's say 100. What is my y? What is the y, guys? Right, 210. If I make x equals to 0.1, what is the y? What is the y, guys? 10.2, right? Okay, cool. Yes. So if you see, guys, here, based upon my slope m and the intercept c, if my input x is, it takes 5, the value of y is 20. If x is 100, y is 210, x is 0.1, y is 10.2. And last, if I put x equals to 0, that means by chance if my input value is 0, what is the output, guys? If x is 0, what is the output? Guys, if my x is 0, what is the output? Yes, it will be 10, right? That is nothing but the c. So if x is 0, this m into x will become 0. And we only left with the c value, that is a 10. So this 10 we are getting because of this c. Now let's assume we don't have this c component. Let's say we don't have this c component. And if my input by chance it will become 0. So what about the output, guys? That will become the 0, right? If you don't have a c. So to avoid this kind of a situation, that yes, so to avoid this kind of a situation, that if by chance, by mistake, my input will become 0, the output won't be 0, right? So to get this kind of a surety, we have this intercept here. This is what we are, getting in the deep learning with the help of this bias. So in future, if my inputs will become 0 by any chance, the output can be 0 because of this bias term. Is that clear, guys? Why we have a bias? Yes or no? Yeah. Cool. What about YouTube, guys? Is that clear? Okay. Uh, Ankitaman, yes, there are couple of ways you can choose. You can decide, or you can get a guess like what is the best activation function for based upon your input data. But as per the best practice, if I talk about, most of the times for the hidden layers, we are going with the ReLU as the activation function. This is for the hidden layer, right? But yeah, there are a couple of ways you can tune this one. They will provide you what is the best, or the optimum value of the hyperparameter, or what you can say the activation function based upon your input data, right? Okay, guys. Any other questions? Anyone? Okay, so I guess this part is clear to you guys, right? Let me come back to this one. Okay. So guys, these are the couple of details regarding the neural network part, right? And this is like, let me just show you. Okay, so this is what, I mean, this diagram is plain. If you have let's say 3 inputs, x1, x2, x3, with weight w1, w2, and w3. So first one, what we have a adder function, and also we have a bias connection, right? So that is missing here as a value 1, but weight as a w1. So first of all, we have a adder function. Whatever output is being generated by this adder function, that is the input to the activation function. And activation function, whatever output generates, that is the final output for this particular node. All right. And this is a typical example, guys, how the things will be processed at the backend. For example, if I explain you this one, for example, guys, let's suppose we have this kind of a neural network where this is the input layer. As I told you, the first layer will always be the input layer. Last layer will always be the output layer. All right. And in between, guys, how many hidden layers I have in this network? Can you guys tell me how many hidden layers I have? One, right? I have only one hidden layer, this one. So likewise, I have one input layer, one hidden layer, one output layer. And let's suppose for the input layer, these are the inputs. So the first node, the input is a 0.05. Second node, the input is a 0.10. And whatever these gray connections you are seeing, these are the bias for each and every node, except the input layer node. All right. And whatever this, 0.15, 0.20, these things you're seeing, these are the some weight value assigned to each and every input. All right. So if I talk about a typical processing, so as I told you, each and every node will perform two things. One is the adder function. Another one is the activation function. Right. So let's see how this H1 will generate the final outcome. I mean, what is the final output of this H1 node? So if you see this H1 node, what are the inputs? So this is the first input. This input value is 0.05 with the weightage 0.15. I2 is another input, right? And the third input is this bias connection with the weight value is a 0.35. So what is the adder function output for node H1? That is a net H1. W1 I1, that is a 0.05 multiplied by 0.15 plus W2 I2, 0.10 multiplied by 0.20 plus bias 0.35. So this is the outcome of the adder function for the node H1. Now this is the input for the activation function. And let's suppose we are using sigmoid as the activation function. For example, and this sigmoid activation function, the formula is 1 upon 1 plus e to the power minus x. So this x is the outcome of your adder function. Adder function output is this one. So just put this value in place of x, this one. And if you solve this one, this is the final output is being produced by node H1. So I mean, in that way, the processing will happen at the backend. Here, guys. Any questions up to this part? Okay, so I hope this part is clear to you guys. And the same thing will get performed by node H2. output node O1, output node O2. All right. What do you mean by machine level language, Apurva? Are you talking about the binary kind of operations? Okay. Yes. So at the backend, computer can only understand 0 or 1, right? But this is what we can, understand. We can understand how this 0.05 is being explained by the computer. All right. So for our understanding, we can use this input as it is. W2 I2 should be 0.25 into I1. W2 I2. Apurva, okay. So W2 is this one, 0.20. That is for this particular connection. Right? So don't get confused with 0.25 for this. I mean, for this connection. 0.25 is for this connection. All right? How to apply activation function on H1. So Abdul, this is how we can decide when we are, designing this network. I mean, when you are writing the code to design this network, then and there you can define the activation function for each and every layer. Don't worry, I will show you one hands-on, like how you can design a neural network. Probably the artificial neural network, ANN. Right? Anurup, this is what I'm saying you. This 0.20, this WI2 is for this particular connection, this particular input. This W3 is for this input. Right? So in that way, just, adjust this one. Okay, so this is what we have a typical neural network and how the processing is being done. And this is what we have a, activation function. So up to this, guys, any doubt or any questions, anyone? Any questions, guys? YouTube guys? Teach you these, sigmoid, softmax, 10H, ReLU, threshold. These are the different activation functions we have. They work based upon certain logic or certain formula. So whatever formula I showed you, so based upon that, it will generate the outcome. Right? So, I mean, it's up to you, like what activation function you want to apply for your input data. Okay. Okay, guys. So this is one thing what I need to cover for you guys. So in the next part, let me just show you a couple of hands-on with the ChatGPT, right? Yes, Sumona, you can get the output. So let me just show you a couple of hands-on with the ChatGPT. And then probably in the next session, I will show you how you can build these kind of architectures, right? So give me a minute so that I will be ready with the ChatGPT. You guys can also, open your ChatGPT account if you want to do the things parallelly. Okay, guys, let me share my screen. Is it visible to all of you guys? Okay, cool. Yeah, thank you, guys. So let's see a couple of more details, right, with respect to the ChatGPT part. So yesterday we saw like how we can provide the prompt to the ChatGPT and how ChatGPT can generate the response. All right. Apart from that, we also saw how we can modify the output as per our need. Even we can also modify our past prompts. Right. So all of those things we understood from the last session. And then we have also discussed one very important concept, the concept of the context awareness. So ChatGPT can understand the context for a particular session, right? Thank you, Simona. We'll do that. Don't worry. So ChatGPT can, it can understand the context. It has a context awareness, but for a particular session. If you change the session, then the context awareness will get lost. So this is what we have understood from the past sessions. All right. Guys, attendance link is there in the chat box. Please mark your attendance. Okay. So let me show you a couple of more details regarding this. So let me start like this. Okay. So yesterday, we saw this particular example prompt. Like if you want to create a table with two columns, one is the column with the tallest building name across the world, and the second one is the height of this building. So like this. So this is what we saw like yesterday's session, right? And we also saw that if you run the same prompt again and again, probably each and every time you will be getting some different outcome. The output will not be same if you run the same prompt again and again. Right? So this time I'm getting the table like this. Okay. Now, then we also saw how we can sort this table based upon any of the feature or the column. So right now, whatever is the, this table is provided by the ChatGPT, it is sorted based upon the height. It is in descending order, right? Let's say I want to sort this table based upon the building name. So this is what we saw yesterday also. Let me just do that. Sort this table by building name. So building name is a, it's a text information. So it is sorting in alphabetical order. So this is what we are getting, right? Now let's suppose, guys, in this table, I want to add another column. Let's say I want to add the country where this buildings resides. All right. So I can ask ChatGPT to add a new column of country. So include another column as country name. So you can see here, it is including a column as a country name also. And this is something we have a height. So we have a height, country, and the name of the building. Right? I mean, this kind of things you can do with the help of ChatGPT. All right. Nitya attendance link is shared by Chandna over this chat box, right? Please check your chat box. Okay, so this is what we saw from the yesterday session. Let's see a couple of more details, guys. Let's say I want to get a summary not for an article, but for a book. And I'm not going to provide the content for the book. I will only provide the name of the book. Let's say, you are interested, in like getting the summary of a particular novel, or let's say any of the autobiography. So you can just provide the name of this novels or autobiography, and you can get the summary. All right. So this is what you can get. So for example, let me just do that. So let's say I want to get a summary of the book Wings of Fire. I'm sure all of you guys know this particular autobiography by APJ Abdul Kalam. All right. So let's say I want to get the summary of a book Wings of Fire. I'm not going to provide like what is the content present in this particular book. I'm just providing the name of this particular autobiography. Let's see what ChatGPT generates. Okay, cool. So this is what guys ChatGPT is generating. It is saying Wings of Fire is an autobiography of Dr. APJ Abdul Kalam, served as 11th President of India. And then this book provides a detailed account of his life from his early childhood in a small village to his rise as a prominent scientist, later a statesman. And then here we have a couple of more details regarding what this book is all about. Right? Let's suppose I want to, get a summary in a bullet points. This is also you can do. Provide summary in, let's say, 10 bullet points. Now you can get the summary in 10 bullet points. Right? Even, let's suppose guys, based upon this particular autobiography, I want to write a blog, a professional blog. Right? So that is also, I can ask ChatGPT to provide write a professional blog based upon this particular novel. This is also I can do that. So I can ask ChatGPT, write it in a nicely formatted professional blog post. Let's see. So based upon this particular autobiography, guys, you can even get a professional blog and you can just copy and paste it over the respective platform. Right? Even you can, if you're not satisfied with this, these details, you can ask ChatGPT to include more details. So let me ask GPT, include more details. And let's say I'm not interested in this, point by point kind of blog post. I'm interested in a paragraph kind of a blog. So include more details and write it in paragraph. All right. Now you can see, guys, instead of getting the blog post as a point by point, now I'm getting a little bit more detail and in a paragraph kind of a format. All right. So I mean, all of these things you can do with the help of ChatGPT. You can change the response of the ChatGPT as per your need. Sumona, you can't search any research paper in the ChatGPT, right? Like it's not a live tool. It will provide the details, whatever it has at the back end. Right? So this is what you can performed with the ChatGPT. So guys, this ChatGPT, it is not providing a live, like it is not generating the response as a live. It is providing you the response, whatever is present at the back end of this particular model. And let me tell you, whatever model is working at the behind of ChatGPT, that model is trained up to the data of Jan 2022. So this ChatGPT doesn't have any information after January 2022. Right? So if you're asking ChatGPT for something which happened after January 2022, so in those cases, probably ChatGPT will not respond to you. For example, let me just show you. All of you guys know, in the month of November, that means in the last month, we had a Cricket World Cup final. Right? So if I ask ChatGPT, provide me the Cricket World Cup 2023 points table. Let me ask ChatGPT. Provide Cricket World Cup 2023 points table. See guys, see the response. ChatGPT is saying, I'm sorry, but I don't have a real time data. Right? And then it is saying, including the latest point table for the Cricket World Cup 2023, as my training only includes information available up to January 2022. That means the ChatGPT contains the information up to January 2022. If you're asking anything which happened after this January 2022, ChatGPT doesn't have that information. Is that clear, guys? Sumana, it's not about when the ChatGPT is launched. It's about how much data is used to train this particular model. So ChatGPT is being launched in this particular 3.5 version is launched in November 2022. Right? So initially, OpenAI has trained, let me just tell you, initially, OpenAI has trained ChatGPT model up to September 2021. Right? Later on, they have again, just trained this particular model up to January 2022. And this model, this ChatGPT was launched in November 2022. Right? The model was launched in November 2022. At that time, it was trained up to September 2021. But later on, recently, the researchers of the OpenAI team has trained this model up to January 2022. Okay. Yes. Yes, Neha, you can, you can get a summary of any of the research article. All right. So Abhishek, as I told you, initially it was trained up to September 2021, but recently OpenAI team has trained, retrained this model up to January 2022. Yes, Amrita. So, like on a regular interval, researchers are training, lots of text data to this model. Abhishek, I will, hold on your question. I will come to your point after 3 or 4 sessions. Okay. So, I mean, this is how ChatGPT works, guys. Is that clear? Okay. So, this is what I need to share with you guys for today's session. And the next session will be on, I guess, 2nd of January, right? 2024 on Tuesday, right? So probably we'll do a couple of more hands-on. Along with that, we'll be also seeing some more technical details regarding the neural network design and all. Okay. So any questions, guys, for me? Okay, so if you don't have any question, guys, over to Chandna. If you have any question related to certificate or study material, LMS portal access, so for that you can ask your queries to Chandna. Over to Chandna.
Yeah, Vikas, thank you. Guys, hope you enjoy the session. So, is there any queries? Please let me know in the chat box.
Just a minute, Chandna.
Yeah.
There is one query. Yeah. Yes, Amrita, you are correct. So it can be used for a content writing, right? Even you can generate a unique content. So all of these things I will be discussing in upcoming sessions. Okay. Yeah. Thank you. Over to Chandna.
Yeah. Nazur is asking how many days class, sir? This is the 9th day. Still, we have a 6 more days. And one more thing, tomorrow and day after tomorrow, up to Monday. Monday also class is not there. Tuesday again we have a class, okay? So when we get our certificate, after completion this program, within 7 working days, you will get certificate through your emails, okay? Registered emails. So guys, please mark your attendance. Don't miss. It will affect on your certificate, okay? Madam, I forgot to give attendance before 7 days. Okay, so you are not eligible for the certificate. So attendance is mandatory for the certificate, that to 60%, okay? Without attendance, we are not able to give our certificates. Yes, Sumana. Tuesday, we have a class again, okay? Kavita, when the leave means? So Saturday, Sunday, weekdays, sorry, weekends, and Monday is the January 1st, right? We have a holiday. So we'll meet on Tuesday, okay? Hi, ma'am. Monday class unda. No, ledu. So it's okay if we have missed it once or twice. Yeah, like 9 days, you have to mark your attendance. So it will reach 60% attendance. At least 9 days, you have to mark your attendance, okay? Kanishka Agarwal. Yeah, guys, if you don't have any queries, you can leave. And we'll meet on Tuesday, okay? Don't forget. Rohit, I'm sharing the link, attendance link. Please fill your details, okay? So it is called attendance. Uma Devi, kindly share the presentation. So I didn't get your question. You're asking about notes and PPT. Yes, Sumanta. Advance Happy New Year. Same. Wish you the same. Everybody, Happy New Year. Yeah. I will share the PPT in LMS, okay? From YouTube, Abhishek. So, ma'am, how can we'll know my percentage of attendance? So, after completion of this program, please drop an email to edl@xlr.com. Okay, I'm repeating again, edl@xlr.com. So, my team will let you know how much percentage you have. Abhishek, so ma'am, total how many classes left to join? So, remaining 6 days are there, Abhishek. Okay. Abhishek, 6 days left. Okay. So this is the 9th day. We have a 15 days program is this. Okay. Yeah, guys. Advance Happy New Year, everyone. Okay. Any queries? Yeah, Afrin. I think you have a doubt. Please ask me. Please check again. It is open already. Please try again. Yes. Harshada, I'm sharing the mail ID in the chat box. Please take from there. It's edl@xlr.com. Yeah, Abdul. A and ML session materials not showing in my LMS login. Yes, we'll update that. Okay. Abhishek, I have to mail to XLR for the percentage. Not today. After completion of this program. Okay. Ma'am, every day we will attendance feedback fill up the day, ma'am. Jeevita, I didn't get your question. Can you please explain me clearly? Kiran, there is one assessment, the two surprise assessment we are conducting. Um, I think Jivita is asking like all 15 days attendance we can mark at one day. It is not possible. Like daily you have to update, and that too that feedback link is open between 8:30 to 9:30 p.m. Okay? Daily we have to update on between that time. Yeah, Happy New Year to 2024 to all the XLR team, and very thank you for providing so beneficial content. Beneficial content. Yeah, thank you, Abhishek. Wish you the same. Jivita, we are telling daily that you have to mark your attendance. So you are telling I'm not fill the form in the day 1 to 8. I hope you didn't get certificate. You have to attend. You have to mark the feedback, right? Feedback link, right? Sumanta in Hyderabad have office, ma'am. Yeah, we have a office in Hyderabad, Cyber Towers. Guys, I hope there is no more questions. So we'll wind up the session. Jivita, I am attended in 1 to 8 days, ma'am. Okay, so you mark your attendance as well, no? Yeah, that's what I'm telling. You have to fill the feedback form. So in that situation only you will get certificate. Without filling the form, we can't able to give certificates. Kiran, I'm joining only second day after this session. Kiran, how many days you attended and how many days you mark your attendance? Guys, 9 days is mandatory. So make sure 9 days you have to fill the attendance. Okay, then we'll wrap it up for today and we'll meet on Tuesday. Okay, up to then, take care. Bye bye and advance Happy New Year, everyone. Have a great night. Bye bye.